Hello students, welcome to second competitive lecture of chemistry in everyday life. So in previous lecture we discussed about some additional types of drugs, and now let's discuss the next point. So just like drugs, some points will be already covered in textbook and additional point will be discussed here. So first, chemical in food. So many chemicals are added to food for their preservation and enhancing their appeal. This includes flavoring, sweeteners, dyes, antioxidants, fortifiers, emulsifiers, and anti-foaming agents. With the exception of the preservatives, fortifying agents, antioxidants, and artificial sweeteners, the remaining classes of chemicals mentioned above are added either for the ease in the processing or for cosmetic purpose. In real sense, these have no nutritive values. So first is antioxidant, and we already covered antioxidant in our regular syllabus, so you can go and check it. Second one will be preservatives. The preservatives prevent spoilage of food due to the microbial growth. The most common preservative used is sodium benzoate. It is metabolized by the conversion of the hippuric acid and which ultimately is extracted in the urine. Salt of propanoic acid and sorbic acids are also used for preservatives. Then we have artificial sweetener, and just like the first, we already discussed about the artificial sweeteners in textbook. Spread, they are used to color everything from meat to fruit. For example, dye are used to dye orange peels so that orange retains their color. Color is one of the ingredient in the fruit juice. There is a great deal of controversy over the potential harm the dye may cause. This controversy becomes more meaningful, particularly keeping in the view the fact that the food dyes are add nothing to the nutritive values in the food. That means they are for cosmetic purpose only. They do not add any type of nutritive values. The use of azo dye has raised considerable anxiety in the some of them are dangerous for young children and asthma patients. Tetrazine, a very widely used dye, is especially a suspect. However, natural dyes like carotene is safe food editable color. That means, as for example, orange color of carrots are because of carotene. For protection of a consumer interest, the government of India have passed Prevention of Food Adulteration Act PFA. And now let's move towards the last point of this competitive topic, the new high performance materials. So first is carbon fiber. These fibers are stronger than steel, stiffer than the titanium, and lighter than the aluminium. Carbon fibers are produced in a number of ways and form a variety of starting materials or precursors such as viscous rayon, polyacrylonitrile, pitch, resin, gases such as methane and benzene. Their characteristics are strongly influenced by the manufacturing technique employed. Carbon fiber reinforced in a lightweight matrix, generally an epoxy resin, polyester resin, or polyamide, are called carbon fiber reinforced plastic or CFRP. When the carbon fiber are reinforced in the carbon matrix, they are known as carbon fiber reinforced carbon, that means CFRC, commonly known as carbon-carbon composite. On the basis of characteristics of carbon fiber reinforced plastics CFRP and carbon fiber reinforced carbon CFRC, their applications can be broadly classified into three categories. So high technology sector including aerospace, military and nuclear field. So very important sector. Second, general engineering sector including sports, transportation and chemical fields. And last, biomedical sectors. So carbon fiber materials are extremely strong and they are very heat resistive. So we can use it in multiple different ways. Carbon fiber in India are mainly used in the defense sector as the nose tips and head shields of the missiles like Agni by DRDO Hyderabad, and in the aerospace sector by ISRO and other aerospace organizations for producing components, parts, nozzles of rockets and missiles. Now second important type of compound is ceramic. The term ceramic comes from the Greek word keramikos, which means burnt stuff, indicating thereby that desirable property of these materials are normally achieved through a high temperature heat treatment process called firing. In the past, most important materials in this class were the traditional ceramics prepared by clay, kaolonite, a silicate. In the category of the traditional ceramics, we have porcelain, bricks, tiles, glass, temperature resistant ceramics, etc. Most ceramic materials fall into the application classification scheme which is given below. So first, clay products, porcelain, pottery, tableware, sanitizing fittings and building bricks, tiles and sewer pipes. Second, glass ceramics used in kitchenwares. Refractory materials, refractory bricks used as furnace lining because they are highly heat resistant. Abrasive ceramics, cutting and grinding tools. Familiar examples are silicon and tungsten carbides. Recently, a family of ceramics have been found to be superconductors with high critical temperatures. One such material is yttrium barium copper oxide, which has a critical temperature about 92 Kelvin. A superconductor ceramic material reported to have even higher critical temperature have been and very currently being developed. Now keep in mind higher critical temperature, that means we are moving towards the normal temperature. Critical temperature are very low for such compounds. So here mentioned word higher critical temperature actually represents it is easy to obtain, not hard to obtain, because if critical temperature is low, it represents very cold temperature, and if we are increasing the temperature, that means we are increasing heat, that means we need less cooled temperature or environment to use ceramic as superconductor. Several of these materials and their critical temperatures are listed below. So in this table, as we can see, some material and the elements used in that material and critical temperatures are mentioned in kelvins. So first element has 92 kelvins of critical temperature and last has 153. So that means first material acts as superconductor at very low temperature than the last material. And we have numerous applications of the superconducting material. Some of them are mentioned as follow: the electrical power transmission, magnets for high energy particle accelerators, and high speed switching and signal transmission for computers. So all of these uses are extremely useful for future technologies.